Can you imagine nearly doubling an engine's power without doubling its size? Sounds like magic, right? Well, that's exactly what millions of people thought when they first started hearing about a part called a turbo. And here's something interesting. A lot of people believe the turbo creates power out of nowhere, as if there were a tiny mechanical goblin hidden inside the engine, pushing the pistons harder. But no. The reality is much more interesting. In fact, to understand how a turbo works, we first have to understand something very simple. An engine works by burning fuel and air. And here's the key. It doesn't matter how much fuel you add. If you don't have enough air, you won't be able to create a bigger combustion. It's like trying to light a huge bonfire with very little oxygen. It simply doesn't work. So some engineers began to ask themselves a question. What if we could get more air into the engine? More air means more fuel. More fuel means bigger explosions. And bigger explosions mean more power. So far, the theory sounded fantastic. The problem was finding an efficient way to do it. And then someone had a brilliant idea. An idea so smart that it ended up changing the automotive industry forever. Because they discovered that engines were constantly wasting energy. And all that energy was leaving through the exhaust. Yes, through the very same exhaust that we normally only see expelling gases. What seemed like waste ended up becoming one of the most powerful tools of modern engineering. And that is exactly where the story of the turbo begins. Now, imagine this. Every time combustion occurs inside the engine, the burned gases are blasted out into the exhaust system. They come out hot. They come out fast. They come out loaded with energy. And normally they just disappear. But the turbo takes advantage of that energy before it can fully escape. How? Well, inside the turbo there is a small turbine. When the gases pass through it, they make it spin. And we're not talking about normal speeds. We're talking about tens or even hundreds of thousands of revolutions per minute. A true mechanical madness. Now comes the interesting part. That turbine is connected by a shaft to another wheel located on the intake side. And while one spins thanks to the exhaust gases, the other begins to compress fresh air. Yes. The turbo works like a kind of extremely powerful fan. It takes air from outside. It compresses it. And it pushes it into the engine. Suddenly, the engine receives much more air than it normally would. And since it now has more air available, it can also burn more fuel. The result: more power, more torque, more performance, all using energy that used to simply be wasted. And this is where many people fall in love with turbo engines. Because they manage to deliver impressive performance without needing to massively increase the engine size. But be careful. All that speed and all that power also create new challenges. What if I told you that one of the most important parts for a turbo's survival doesn't even generate power? That's right. We're talking about engine oil. And if you already watched the video where we explained why oil is so important, you probably remember that we mentioned something fundamental. Oil doesn't just lubricate. It also helps cool components. And in the case of the turbo, that is absolutely vital. Think for a moment about what's happening. You have a turbine spinning at absurdly high speeds. You have enormous temperatures coming from the exhaust gases. You have constant friction. All of that happens inside a relatively small space. Without proper lubrication, the wear would be devastating. That's why oil continuously circulates through the inside of the turbo. It lubricates the shaft. It reduces friction. It helps dissipate heat. And it allows everything to keep working properly. In fact, many turbo problems begin precisely when there are oil-related failures. Contaminated oil. Late oil changes. Poor lubrication. All of that can significantly shorten the system's lifespan. So, if you still haven't watched our video about engine oil, I recommend looking for it after finishing this episode. Because you'll understand perfectly why something so seemingly simple can save extremely expensive components.
And trust me,
when we talk about turbos, we're talking about parts that are not usually cheap. But there's still something even more interesting. Because the turbo doesn't just increase power. It also completely changed the way manufacturers design engines. Imagine two engines. One big, another smaller one. Several decades ago, if you wanted more power, you usually needed to increase displacement. More size. More weight. More fuel consumption. That was the traditional solution. But with the arrival of modern turbos, something different happened. Manufacturers began to ask themselves, why not use smaller engines and help them with a turbo? And so a trend appeared that today we see practically all over the world. Compact engines capable of generating power that once required much larger sizes. This made it possible to reduce fuel consumption in certain situations, improve efficiency, and make better use of available space. Of course, it's not all advantages, because a turbo system adds complexity. More components, more heat, greater mechanical demands. And that means maintenance is still important. Very important. For example, something as simple as shutting off an extremely hot engine immediately after demanding driving may not be the best idea in certain cases, because the turbo is still building up heat. And precisely for that reason, many manufacturers developed different strategies to protect these systems. What's fascinating is that we're talking about a technology that has been evolving for decades. And yet it remains fundamental in countless vehicles today. From small city cars to huge freight trucks. The basic concept remains the same. Use wasted energy to generate more air, and use that air to produce more power. Now comes an interesting question. If turbos are so good, why don't all engines use them? And the answer is simple. Because in engineering, everything involves trade-offs. Always. Adding a turbo can offer huge benefits, but it also increases complexity. It requires additional systems. It creates new thermal demands. And it forces you to design components prepared to withstand more extreme conditions. That's why there are naturally aspirated engines that work perfectly well without needing a turbo. And that's also why there are turbocharged engines capable of delivering impressive performance. No solution is perfect for absolutely every scenario. What matters is understanding what problem each technology is trying to solve. And in the case of the turbo, the goal was always very clear. to get more performance by taking advantage of energy that would otherwise be lost. That is the true brilliance behind the invention. Not creating new energy, not generating power out of nowhere, but reusing something that was already there, waiting to be harnessed. And that is precisely why engineers tend to admire this system so much, because it represents one of the most elegant ideas in all of modern mechanics. So the next time you hear someone say their vehicle has a turbo, you'll already know that behind those few letters there's a fascinating story of physics, engineering, and efficiency. You'll know that inside the system there's a turbine spinning at incredible speeds. You'll know that the exhaust gases are doing far more work than you imagined. And you'll know that an important part of that whole operation depends on something as seemingly simple as engine oil.
Because yes,
sometimes the most important parts are precisely the ones that get the least attention. And if you like this kind of explanation where we take complex technologies apart to understand them in a simple way, subscribe because there are still many stories left to discover. Stories about engines, about engineering, about inventions that changed the world, and about those parts we use every day without stopping to think about how they really work. Because when you understand how a turbo works, you stop hearing only the sound of the engine. You start hearing decades of innovation working all at once. You start to understand why a relatively small part can completely transform a vehicle's behavior. And you begin to see mechanics with different eyes. If you also want to understand why oil is so important for the survival of components like this, don't forget to watch the previous video. Because both stories are much more connected than they seem. And once you understand that connection, you begin to discover something fascinating. That behind every great mechanical system, there are dozens of small parts working together. Each one fulfilling a function. Each one playing an essential role. And each one helping move the modern world we know today.